We're here to have a demonstration of the dual force hydropower system. This is a model of the system and it's contained in U.S. Patent 6933624. We're going to start with an explanation of all the system components, then we'll add the water and get it started. We're going to start with the upper water tank. This represents our upper water source. It contains our upper turbine located in here. The turbine is contained in these bearings. The bearings support rotation and the weight of the turbine. They're in these alignment arms so that we can align the shaft in the tank. As water goes through the turbine and exits the tank, it goes through this plumbing system down here into a Y valve. There's a Y valve here and there's another one on the exit side, on the far side. The purpose of the Y valves is to feed water into the chambers selectively. One is filling and one is draining at all times. So the valve is on open for one and closed for the other. The Y valve on the other side is just the opposite. That allows one chamber to fill and the other to drain at all times. These are the chambers number 1 and number 2. They contain buoyant objects 1 and 2. The buoyant objects drive this shaft, you see across here, through this system of chains, arms, gears, and recoil systems. The arms with the chains on them operate in the upstroke. The chains attached directly to the buoyant objects operate in the downstroke. They drive this shaft through these gears, which is our bicycle gears. They operate in one direction only. The recoils reset the gears at the completion of each stroke so that they're ready for the next cycle. As the water enters the chambers through this plumbing down here, there's a T at the bottom of the chamber to feed it in and drain it out. The chambers are always going to be half full. The buoyant objects here weigh 45 pounds each, so they're always going to be partially submerged. Our operating distance is only 5 inches on this system. You can see the mark here on the side of the tank at 5 inches, the bottom of the tank, over here. So there's always going to be this much water in the chamber. Then from here up is the operating distance. On the downstroke, the chamber is draining and the water will be exiting. It'll come through this Y valve over to our lower water tank. The lower water tank is again 5 inches below the maximum height of the upper water tank. It contains our lower turbine, which operates very much just like the upper turbine. As the water enters the tank, it operates the turbine. We then have a bilge pump for recirculating the water back to the upper tank, because we don't have a stream in our basement here to operate this system, so we have to recirculate the water. It operates off a regular battery. Lastly, this is a drain for the system. When the system's not being used or demonstrated, we drain it to avoid any accidents or leaks in our basement. So now we'll go ahead and put water in the system and fire it up. Alright, we're back for the demonstration of the dual force hydropower system. This is the model. We've added the key ingredient, which is water. The system is essentially off right now. In the off position, one buoyant object is up at its maximum height, the other's down in the drained situation, and the system is not functioning. You can see the turbines aren't turning. We've added a little toothpick to the top there so you can see the shafts rotating. This one's also off. Now we're going to start the system, and basically all we have to do to start the system is shift the valves, which will open the floodgate, so to speak, for the chamber that's going to be filling and drain the chamber that is already full. So here we go. And now we're also going to start our pump. And you can see the turbines are now turning. And you can see our buoyant objects. Number 2 is rising. Number 1 is draining into the drainage or lower water tank over there. You can see on the rotation of the shaft, we have this pen taped to it to give a good view of it. We put plexiglass in this chamber number 1 so we could see what was happening. We also added a little bit of red food dye to the water so that would be easier to see. The noise you hear is the pump running, recirculating our water. You see, occasionally our springs don't want to operate quite the way we'd like on this model. Now that increase in noise means the pump is running dry, which means also basically that a cycle has basically completed. Ordinarily, well, in this model, we shift the valves by hand using this lever here. In an actual production situation, these valves would be actuated valves or power operated valves. You can see our turbines spinning. Now, the purpose of each of the turbines is, of course, to generate electricity, generate power using the turbines, and then we can also generate power from this shaft that the buoyant objects operate. One is always rising, the other is always draining, so we always have good power being applied to the shaft, which is rotating. Of course, when you have rotation, you can operate a generator. All of the details, calculations, full descriptions, and all that are, of course, in the rest of the information on the website. Now we have this one is about maxed out, and the other one's pretty much drained. So we'll go ahead and shift. Get a shot of that guy spinning there. And you see that both of these turbines do work. You see that guy over there spinning. And you can see our buoyant objects rising and falling and rotating the shaft. Well, that about concludes this demonstration. We hope you find it informative. We've actually had some fun doing this.